In this video, I'm going to show how to program the microbit in order to follow the steps from the article in STEM PD. For that, you will need to go onto the page makecode.microbit.org, where you can then start a new project. However, it is possible to change the language into any other language available, amongst them German, English, Turkish, and so on. So in order to start, you will need to do a new project and find a name. In this case, we will use the name STEM PD1. Click Create, and you will be put onto the page where you can do the programming. As you can see here, you can add the code, and over here on the left side, you have the actual microbit to simulate the programming. So the first part we will do is we will read the sensor, and a sensor is an input, and so for that we will need to find the acceleration button, and this is now gray and crossed out as it is not yet available. We need to tell the microcontroller what to do, and for that we will tell him show a number, as the reading of the acceleration is a number. You can see that this is round and the show number field is also round, and we put all of that into the forever loop, and now the microbit will show us the acceleration in a forever loop. And we can simulate that here by tilting the microbit, and it simulates what is going to happen, and we can see how the number is automatically running through it, and we can see now it is working on the X direction. We can also change that into the Y direction, and after a brief pause, we can see that now we can tilt the microbit around a different axis, and again, we get different readings. So this is how to use the acceleration. Okay, we'll just change that back to X and continue. So now, currently, the microbit would show the number of acceleration at all time. So what we want to do now is we don't want to have it doing it permanently. We want that to happen with an if condition. And so we will need to go into logic and pull out this one. And again, it is crossed out. So we move the show number into our if condition and move the if condition into our forever loop. By the way, we don't need the on start loop, and so I'll just briefly show how to get rid of it, like that. Okay, so now that we have the forever loop, we still need a condition for if, and for that we want to say if button A is pressed. So we need to go into input, button A is pressed, fits perfectly, and now we can say we want our acceleration read when button A is pressed. And we get our display information, as you can see. Well, it's kind of a mistake of the simulation that we can only use full tilt here, but basically on the real microbit, it works with whatever tilt you will use. Okay, so now that would be a condition with a pressed button. And now what we want to do is we want to add the y-axis as well. And so we can add a second if condition. We could do it like that, or we can simply duplicate our first one and just change A to B and X to Y, and now if we press button B, we get our Y tilt. A still gives us our A tilt, and B gives us our Y tilt, minus 33. It's also displayed on it. Okay, now we have two different blocks. And what we want to do next is we want to show icons. So we'll just, for now, throw out those two. We can keep them for later. Here, they don't do any harm. And we'll just briefly look at show icon. Here we have a set of predefined icons that we can simply use to illustrate whatever we want to do. And so we can just for now use the sad smiley for B and use the happy smiley for A. And that is basically what has been put into our example in STEM PD. And so now if we press A, there is a happy smiley and it will stay on forever. And there is a sad smiley pressing B. So if we want to get rid of our smileys, so far we haven't set any conditions for that. So we need to add that. And so we'll add another if condition here. Move those a bit out of the way. And we don't want to show any icons anymore. We want to show blank, no LEDs. And we want that to happen when A and B is pressed together. So in our simulation, we now get an extra button that isn't actually on the microbit. It's just because with a mouse, you cannot press A and B simultaneously. So let's go through it. A, B, and A and oh, that should actually turn the thing off. That must be a mistake in the simulation. So usually if you would press button A and B, then it would turn off the microbit. So I'm a bit confused here why that is happening. So let's just restart the simulation. Yeah, so this is a mistake with the simulation. In reality, that wouldn't happen. Well, as the program is free, I guess we have to live with slight deficits. Okay, after that, we now want to look at individual LEDs being turned on and off. And so for that, we'll just get rid of these. And now we can add to the LED field, and we can use the plot function. And for that one, we want to turn on the LED with the coordinates 2 and 2. And we want to turn them off with B, so we need to unplot them. And we have to specify that we want to unplot 2 and 2. So hopefully that should work now. That's the middle one. And yeah, now it works. Turn it on, turn it off. The microbit has a slightly different way of counting. So it starts counting in the top left corner with 0, 0. You can see that in the simulation, it gets displayed. 1, 1, and 2, 2. So turn it on, turn it off. Quite simple. And we will later need that in our game to have the LEDs run towards one direction and then towards the other one. And so what we want to do now, lastly, is we don't want to press any buttons, but we want to use our acceleration as an indicator for our if condition. So we'll just turn out those again. And now we need to get rid of these as well because we want to use our acceleration. So for that, we need to define our conditions. And for that, we need the smaller, larger one. So for one, we use the acceleration on the x-axis. If it is smaller than a certain value, now it is 0, then something should happen. And of course, for the other one, we want the x-axis to be larger than 0. Now, if you are a keen mathematician, you will now automatically see that there is a problem. We didn't define 0. As this is smaller than 0, this is bigger than 0, the computer won't know what to do at 0. So one of them we need to change into larger equal or smaller equal. Okay, and so now we will choose our icons again. And one time we will use the happy smiley. And one time we will use our sad smiley. And what we should have now is, well, the condition is it is 0. So we have the sad smiley. And if our condition is smaller than 0, we have the happy smiley. And here we go. We turn over to sad smiley. And this way we have a physical input, namely the acceleration on the x-axis, that will change the output of our microbit. Later on, we will use the same function to make an LED run over the screen, but so far we only use it for our smileys. And with that, we basically end our STEM-PD part, and you can be happy to hear that there will be more coming, namely showing how the LED will run over the screen. So good luck with coding and best wishes.